Here we're going to go through the calculations for the question 2 titration question in the 2016 ordinary level paper. So we're told at the top of the question that the concentration of a sodium hydroxide solution was found by titration with a 0.1 molar hydrochloric acid solution using an indicator to identify the endpoint. It was found that exactly 25 mils of the sodium hydroxide solution required on average 22.5 mils of the 0.1 molar hydrochloric acid solution for neutralization. The equation for the reaction is given there below, and we are asked to calculate the concentration of the sodium hydroxide solution in moles per litre and then in grams per litre. So before I do any of these calculations, what I'm going to do is I'm going to go to all of that information and I'm just going to identify what information belongs to which chemical. So if I see here that I have 25 mils of sodium hydroxide, and that's this chemical here in the equation. So the 25 mils of the sodium hydroxide, and there it is identified in the equation. And then what else do I have? I have 0.1 molar hydrochloric acid. It was found that 25 mils of sodium hydroxide solution required on average 22.5 mils of this 0.1 molar hydrochloric acid. So there's information about that, and in the equation there's the hydrochloric acid. Just so I know which numbers in the information belong to which chemical. So now what I need to get to find the molarity or the concentration of the sodium hydroxide, we're going to first write down what information we have. So my acid is HCl, my base is NaOH. So what do I know? Do I know the molarity of the acid, M1? The molarity of the acid from above we can see is 0.10 molar. So I do know that. Then V1, the volume of acid I used. Do I know how much acid I was using? So we can see as well up there in the blue that we used 22.5 centimeters cubed. So 22.5 centimeters cubed. And then finally N1. So that's the number of moles. And by number of moles we mean what number is in front of HCl in the balanced equation. So if we look at the balanced equation, there is no number there. That means there's in fact a 1. So the big number in front is 1, N1. Now we try and do the same thing for our base. So do I know the concentration of the base I used? And no, I don't. That's what I'm actually being asked to find, the concentration of the sodium hydroxide. Do I know what volume of sodium hydroxide I used? So up in the yellow we can see that there was 25 centimeters cubed used. And then finally, what's the big number in the equation in front of sodium hydroxide? So again, because there's no number written in, that means there's a 1. So I have a 1 down there. So once I have all that information, I can get on to using the formula. So the formula is M1 times V1 over N1 equals M2 times V2 over N2. And I have all of those numbers back across here, so I'm just going to substitute them in. So M1 is 0.10 times V1, which is 22.5, all over N1, which is 1. And that's going to be equal to M2, which I don't know, so I'm just going to leave it as M2, multiplied by V2, which I know is 25, divided by N2, which is 1. Okay, so that's that finished. So I'm going to evaluate the left hand side, and we get 2.25 equals 25 M2. So that's both sides just evaluated there. And now to get M2, I need to divide by 25. So M2, which is the concentration of my sodium hydroxide, is 0.09, and this formula always gives you your answer in moles per litre. Always moles per litre, nothing else. And of sodium hydroxide, because M2 was for the sodium hydroxide. So that's part 1 finished. That is, calculate the concentration of the sodium hydroxide solution in moles per litre. That's done. Now I need it in grams per litre. So to turn moles per litre, this value, into grams per litre, what we need to do is multiply the 0.09 by the molecular mass of sodium hydroxide. So to get the molecular mass of sodium hydroxide, so sodium is 23, oxygen 16, hydrogen is a 1, that gives us 40, so I need to take my 0.09 and multiply by 40, and that gives me my concentration as 3.6 grams per litre sodium hydroxide. And that's that part done. Calculations finished.